31 is on graphs of sine and cosine. So we kind of looked at this a little bit yesterday. So basically we said if we think about the unit circle and we think about what the sine of 0 is, the sine of 0 is right here. And that's the point 1, 0, which means that we have a sine of 0, right? Yeah. Do you need this? Do you not have this? So then when we go all the way up to pi over 2, our sine value changes. So this goes to the point 1, 0. Geez, why did I say 1, 0? 0, 1. Are you guys like, this is cox? Which has a sine value of 1. So basically our sine, when we move from 0 to pi over 2, we go from a height of 0 to a height of 1, right? So on our unit circle, or on our corresponding graph, when I go from 0 to pi over 2, I go from a height of 0 to a height of 1. Okay, we talked about that yesterday as we used the whiteboards. Okay, but then we can think about, well, what happens as I go from pi over 2 to pi? So as I'm moving from pi over 2 to pi, my sine, right, sine of pi over 2 was 1, and then sine of pi was 0. So now I go back from a height of 1 down to a height of 0, right? So that's going to be the part where we have pi over 2 to pi, and we go from that height of 1 back down to 0. Okay, and you can get other values that are in there. Like for sine, I think good things to try would be like the pi over 6s. So if I had like 5 pi over 6, that's the point negative root 3 over 2, comma 1/2. So 5 pi over 6 would be at a height of 1/2. So if you want to talk about 1/2, it's like right around there. So you can get all those other points as well. All right, and then pi to 3 pi over 2, what do we go from? We go from 0 to -1. And then the last one, 3 pi over 2 to 2 pi. We go from -1 back to 0. Okay. So it doesn't really make sense when we see it in all these pieces. But if we think about what the whole sine curve looks like, oops. Typically when I'm drawing any sine curve, cosine curve, or whatever, here's what I do, guys. I go out to the full period 2 pi, right, because it completes a full cycle from 0 to 2 pi. And then I have it, and I have it again. So I'm going to have it, pi over 2, and I'm going to have the pi to 2 pi into 3 pi over 2. So we said sine of 0 was 0, sine of pi over 2 was 1, sine of pi was 0, sine of 3 pi over 2 is -1, and then sine of 2 pi is 0. Okay, and if you remember what I said yesterday, I said it's kind of like polynomials. Polynomials are never like this, real jagged. Polynomials were always like smooth and continuous. Okay, same idea here. We don't ever have these like sharp points. So we're going to draw a nice smooth curve that connects. Okay. So this is what we call one period of the sine curve, meaning we started at 0, we went up, back down to 0, down past, and then back up, and now we're starting that cycle again. Does that make sense? So you can draw it on the next, like you can draw extending, so you know, okay, it's going to continue. So that's what it says in the note. It says the same curve will be repeated for different values of t. So what are 2 values of t that give an output of 1? So if I'm on my unit circle and I want to talk about my sine value being 1, it could happen at pi over 2, or it could be 5 pi over 2, right? Going around another 2 pi, adding 4 pi over 2. Or if I wanted the negative value, hey, you always look like you're up to no good. So if I start here, he's just grinning. He's really into the math, I guess. You look like I'm suspicious of you. So if I have the negative, where do I go? I go around. So this would be -3 pi over 2. And then there's an infinite number of answers. Make sense? So the way you might see that written is sine of t minus 2 pi is the same as sine of t. So in other words, the period is 2 pi. So you can add or subtract 2 pi. It could say plus 2 pi here as well if you want. All right. We feel pretty good about graphing sine of x or sine of t or whatever. All right, so same thing for cosine. Yeah. Okay, so think through cosine. Think about what your cosine values are as you go from a radian measure of 0 to a radian measure of 2 pi. So what does cosine go from? As I start at 0, what's cosine of 0? 1. And then if I have cosine of 2 pi, or cosine of pi over 2? 0, right. So I'm going to start at a height of 1 now, and then I'm going to go to a height of 0 for the first part. So I'm going to start at 1, and I'm going to go to 0. Because like we said, this was the point 1, 0, and this is the point 0, 1, so my cosine values go from 1 to 0. So I start at 1, and I go to 0. We can label pi over 2. All right, then if I go from pi over 2 to pi, my cosine value was 0, and then it goes to a cosine value of -1. So I'm going from 0 to -1. And then if I go from pi to 3 pi over 2, what cosine values do I go from? That was -1, 0, and this is 0, -1. So I go from -1 to 0, exactly. So it kind of brings it back. And then the last part, so we're kind of finishing off this full cycle, so it has to go back to its starting point. So originally we started at a height of 1, so it makes sense. If I start at 3 pi and I go to 2 pi, I go from the point 0, -1 to the point 1, 0. So I do go from 0 to 1 for my cosine. Oops, I drew it wrong. It's hard for me to like think about. Okay, up and then that. Okay, so 1. So that was from 3 pi over 2 to 2 pi. Okay. So put it all together into a single curve. So like I said, a lot of times I'll go out to the full cycle, like the full period is 2 pi, and then I'll have it and I'll have it again. And when you do that, you create 5 points. We'll talk a lot about these 5 points. So we have 5 different x values that we're going to use, and that gives us the full period. Okay, so we're starting at a height of 1 for cosine. We go from 1 to 0, then 0 to -1. Whoops, I made my curve kind of weird there. 0 to -1, and then -1 to 0, and then 0 to 1. Okay, it kind of makes like a little U shape on this one, just the ends are kind of curved. Okay, but it continues, so you can draw kind of the ends saying, okay, it continues this way and this way. Okay. So number 1, it says state all values for x for which sine of x is equal to -1. Some people choose not to use the unit circle at all. I find that shocking. I like the unit circle, but we had a teacher a few years ago who loved tracing out the sine curve and the cosine curve, and that's how he did it, which, I don't know, I thought that was hard. But so if I have sine and I want to find where sine is equal to -1, it would be here, 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 right? You could find all those different places. So the first one is when sine is equal to, I would say 3 pi. Or sorry, 3 pi over 2, I mean. And then you would continue by adding 2 pi or subtracting 2 pi. So do you guys remember when we would talk about all values? When I didn't say just on 0 to 2 pi what we would write? So what did I usually write? Plus 2 pi. I usually do 2 pi k. I think Mrs. Hogan does 2 pi n, where k is an integer. You don't have to write where k is an integer each time. I'll know what that means if you just have a k. But basically, if you think back to our unit circle, we're saying when is sine equal to -1? It's equal to -1 down here. And so that's at 3 pi over 2. but you could add 2 pi to get the next rotation. You could add another 2 pi, add another 2 pi, right? Or you could subtract 2 pi, and it keeps taking it to that point every rotation that you do around. Does that make sense, Paloma? Zachary? Okay. All right, so on this one it says state all values for x for which cosine is -1/2. So this is why I didn't like using like the sine curve for this stuff. That's why I like using the unit circle, but I mean, I guess it's up to how you learned it when you were in school, right? So if cosine is -1/2, that to me is kind of hard to estimate. It's like, well, somewhere around here and somewhere around here, right? That's kind of hard to see. So it's okay. If you want to always revert back to your unit circle, you can. So if we're saying when is cosine equal to -1/2, the x value is -1/2 here and here. Okay, so that's when we go over just a little tiny bit and then up a whole bunch. So that's going to be at 2 pi over 3. Because we're pi over 3 away from pi, or we're at 120 degrees, right? 2 pi over 3. It's like 2 of the 60s. And then what about down here? Yeah, 4 pi over 3. Okay, but what happens is it's happening at 2 pi over 3 and 4 pi over 3, and it's continuing. So it's here, and then there's 2 for every single period. Yeah?
So for number 1, why don't we do 2 pi k minus 3 pi over 2?
You could.
As well. Okay.
Well, actually, minus 3 pi over 2 would put it up at the top. Because if you had a negative angle. So she's saying, could you do 2 pi k minus 3 pi over 2? But if you have negative 3 pi over 2, that means you go around the circle this way, and it would put it right up there. Okay, so yeah, you could do 2 pi, you could do 3 pi over 2 minus 2 pi k, though, if you want.
Okay, so it could be either.
It could be either, yeah. If k is an integer, it can be positive or negative, right? So if you add a -1, it's the same as subtracting 1, right? So it's kind of the same idea. I usually do plus, though. All right, so this one is going to be, the way we'd have to write this out is 2 pi over 3 plus 2 pi k and 4 pi over 3 plus 2 pi k. There's no way to like combine those into a single answer. You know how sometimes with like the tangent answers we had every rotation of pi around? Okay, so this is a little bit different. We have to write them separate. Do you guys understand what I'm saying there? Okay. So going back to more unit circle stuff. So on the interval -pi to pi, state all values of x for which sine of x equals -√3 over 2. So sine is equal to -√3 over 2 here and here. Okay, so if you're on the sine curve and it's asking between -pi and pi, it's basically saying when are you at -√3 over 2? There's 2 answers. Again, you don't have to use the sine curve. It's fine. If you want to think about it with the unit circle, I personally think it's easier, but you know, I got my faculty picture with the unit circle, so I love the unit circle. I don't know if you guys do. All right, so what are these 2 values? What do we think? 4 pi over 3 and 5 pi over 3. But here's the trick. That would be on the interval 0 to 2 pi. Okay, so we have an issue. Because we don't want on 0 to 2 pi, we want from 0 to pi. Okay, so we have to do it a little bit differently. Oops. Okay, so if I want to change these values so that they're on -pi to pi, I basically want to add or subtract 2 pi. So if I want, like 4 pi over 3 is bigger than pi, right? So let's try subtracting out pi. So what do we get when we do that? So if you have 4/3 minus 1, it's 4/3 minus 3/3. Or not pi, sorry. Is that why you gave me a big eyebrows there? I saw some of yours. Minus 2 pi. So minus 6 pi over 3. So we're going to have -2 pi over 3. Do you guys see that? So this is the same as -2 pi over 3. Okay, so you can do it that way by subtracting out 2 pi. Or, if you guys look up here, and you talk about the negative angle, doesn't this go backwards by 2 pi over 3? Yeah, you could do it that way as well, where you say, oh, well, I'm just going to go around the unit circle clockwise and get there. Okay, so what does the other one, what do you guys think the other one's going to be then? Negative 1 pi over 3, so negative pi over 3. Exactly, and those are our two answers. Okay, so let's get to the weirder ones. So we're going to use our calculator on the next one. So it says find decimal approximations for the solutions to sine of x equals 0.3. So what this is saying on our sine curve is it's saying when are we at a height of 0.3? Do you guys see it's going to be two answers between 0 and pi? And then it continues. There's going to be an infinite number, right? Does that make sense? Okay, so we can think about it with the sine curve or we can think of it with the unit circle. It doesn't matter. So if I have sine is equal to 0.3, I know my height is at 0.3. It's something here. I mean, those are not unit circle values though, right? We don't know what 0.3 is. Like the only heights we use on the unit circle are heights of 1/2, root 2 over 2, root 3 over 2, 1, and 0. Okay, this isn't one of my unit circle values. Okay, so I need to use my calculator to find the first one. Okay, so what mode do I need to be in? Radians, so change your mode to radians. So hit mode and then highlight radians and hit enter. And I'm trying to solve sine of x equals 0.3. So I'm going to do x equals inverse sine of 0.3. So inverse sine of 0.3. So when I do, I get x is equal to 0.305. Okay, that's a radian measure. Okay, so what a radian measure is kind of the arc length, right? If I was at pi over 2 is like 1.57 something. Okay, it's between a radian measure of 0 and pi over 2. It's closer to here. Does that make sense? Like 0.3 something. Okay, but there's more solutions to this. And we did this last semester, but if you were in Mrs. Hogan's class, you have never seen this. So pay attention if you were in Mrs. Hogan's class, okay? Because she just skipped this part. So this is a distance of 0.305. What about this part here? So if I want the radian measure starting at 0 around to here, how do I get it? Okay, you're close. You're saying 180 minus that answer, but it's not 180, right? It has to be pi, right? So in order to get this one, we say, well, I could start at pi and go backwards that arc length, that 0.305, and I would get my answer. You guys see? Because this is a distance along this is like this distance here. So you're like, well, what if I start with pi and then I go back by that amount? So what do you guys get? Like 0.2 something, or 2.83? Yeah. I usually do 3 decimals, so I would do that. Okay, does that make sense? Do you guys get that? Snyder twins, do you get it? They asked me a lot of these questions right before the final, so. All right, so what are the ranges of f of x equals sine of x and g of x equals cosine of x? We have 2 sets of twins in this class. That's very exciting. You guys didn't even realize that, did you? And a half. I'm a half of the set of twins. All right, so what are the ranges f of x equals sine of x and g of x equals cosine of x? Okay, so let's think about it. Range is all the y values, right? So if I graph out sine of x, what's the highest that I get for sine of x? A height of 1. What's the lowest? -1. Is that the same for cosine of x? Yeah, so the range is going to be -1 to 1. Oh, I guess I didn't, number 4, I didn't say it on 0 to 2 pi. I didn't specify that it was only those answers, so maybe we should do a plus 2 pi k. Right, so you can continue to go around and around and around. All right. Okay, so the next bit of this. So we kind of talked about this yesterday too. So when we had things like y equals x squared, and I wanted to shift it up 3, I would do y equals x squared plus 3, right? If I wanted to do a horizontal stretch by 2, inside parentheses I would put a 1/2 x. right, in order to stretch it by a factor of 2. Do you guys remember all this? Okay, that's what we're going to do, but we're going to do it with the sine and cosine functions. Okay, so we're going to have things that get stretched out, moved up, moved to the right, moved to the left, right? We're going to have lots of things happening. So on number 1, it says list the transformations that change y equals x squared into this function. So let's start with the minus 5. What does that do? It moves it to the right 5. What about the 1/2 out front?
Vertical compression.
Yeah, Greta's on it. Are the rest of you guys on it? So it shrinks it down. All the y values are divided by. So y's divided by 2. How about the plus 4 on the end? Up 4, exactly. Pull them up, you guys done this. Okay. All right, but it gets a little bit tricky. And some math teachers really like mess students up on this. So when you have 2 horizontal transformations, you have to consider pulling that factor out. Because if you graph this, and you can try, a lot of students are going to think, oh, it's going to move to the left 4 because of the plus 4. It doesn't. It only moves to the left 2. Okay, do you guys remember talking about that before? So what we have to do is we have to write it like -1/4, and then we do a big bracket, and we have to pull out this factor of 2. Okay, so I'm going to pull the 2 out here, and when I pull the 2 out, I have an x plus 2 instead. Okay. And if I'm able to simplify a little bit, I usually do. Because I mean, I could say that this is like a vertical compression by 1/4, and it's also a horizontal compression by 2. But if I can combine those, it's usually easier. So do you guys see how we can square the 2 and square the x plus 2? So I'm going to square that 2. So I kind of have that. And then I'm going to multiply that 2 squared, which is 4, by the -1/4. So I kind of like squared that and squared that. So my final form is negative outside x plus 2 squared minus 1. Okay, so there are 3 transformations. So think about what those 3 transformations are. So x plus 2, what do I do? Left 2. How about the negative out front? Greta loves transformations, apparently. Greta, go ahead. Reflection over x-axis. And then the -1, down 1, exactly. So those are the 3 transformations. Okay, so the reason we talk about that in Algebra 2 and also Precalc is because we use this when we talk about other functions as well. So sine and cosine, we have to do that. If you guys don't do that, you're going to get all your answers wrong. So we have to pull out the common factor on the inside. Okay, so it says the same transformations can change sinusoidal functions as well. So this could be sine or cosine. It doesn't matter. So, I mean, your parent function could be either starting at 0 or starting at 1, depending on if you have sine or cosine. So if we have something like this, we first rewrite it. Because do you guys see that we have 2 horizontal transformations? We have this B and this C, right? So we have to rewrite it so it looks like f of x equals A times sine, and then it's like a big parenthesis, b times x plus, what's going to be next to the x plus? If I pull a b out? Close, not c. C divided by, oops, and I went dyslexic on that. Okay, b. And then plus d. Do you guys see it? So if we multiplied this b back in, see how we have bx plus c, like we wanted. So it would have what we call an amplitude. Okay, amplitude is, I don't know how to describe this. So like our amplitude for the original sine and cosine functions is 1. It's how much we go off what I call the equilibrium line. Do you guys see this line in the middle? It's kind of the balancing line. Right, it's how much I go above and below. That's what an amplitude is. Okay, so if we have this new function like this, what changes the amplitude? Our amplitude is affected by vertical stretches and compressions. what number is a vertical stretch or compression? And by number, I mean variable. Just this one right here, A. So it has an amplitude of A. So whatever number's all the way out front is the amplitude. A horizontal stretch or compression, so if I have B, it would be a horizontal stretch of really the reciprocal, 1 over B. We'll put 1 over B. It moves to the right, negative C over B units, and a vertical shift of D. This will make more sense with actual numbers. Don't worry too much about those. That's a C. Yeah, it's not very pretty. This is always the reciprocal. So if you have like a 2x, it's really like a 1/2, right? So it'll make more sense once we have numbers, I promise. All right, so the key is don't memorize this. So a lot of teachers will make their students memorize it, and they'll make like little mistakes because they'll have like B, or they'll forget the negative, or whatever. Don't memorize this. Okay, all we're doing is we're relating it to things we already know. We know transformations, we're going to relate it to that. So let's try it. So it says, list the transformations needed to change the graph of cosine of x into 2 cosine of x minus pi over 2. So sketch a rough graph below, and then check by graphing both equations on the same screen. Okay. So what do we think? What do you think the 2 does out front? It changes what we call the amplitude. What were the words we used in Algebra 2? We said it's a vertical stretch by 2. So in other words, using pre-calc words, it has an amplitude of 2. What about the pi over 2? It moves right, pi over 2. So pre-calc words, we use it something weird. We call it a phase shift by pi over 2. And am I going to be mad if you say right pi over 2? No. But if you see something that says phase shift, that's what they mean. Okay, so let's think about what cosine of x looks like. So cosine of x started at a height of 1. It went down, up, right? So I always draw the 0 to 2 pi. I told you there's 5 important points, right? I have again. You don't have to write like all these numbers along the bottom. I'll be impressed if you do, because some of these are going to be complicated. But at least if you have the halfway, or the end of the period and the middle, write those ones, okay? So cosine originally went like this. Down to -1, up to 0, back to 1. You'll get used to drawing this. We'll draw it a million times. And it continued, so it doesn't end. So this one is going to move to the right by pi over 2. So that means that I'm going to start at pi over 2, and I end, where's the end of my period? 1 period. Add 2 pi to it. At 5 pi over 2. Okay. And it's vertical, it has a vertical stretch by 2. So instead of going up to a height of 1, what am I going to go up to? A height of 2. But it starts, this is kind of like where the new axis is, right? It starts right up here. So right pi over 2, up 2. That's our start point. That's like the original point that was here. Does that make sense? From there, we're going to do our full cycle. So it's going to end back at 5 pi over 2. So if you want to draw it over here and you're like, okay, it's definitely going to end there, what happens in between?
It goes down.
It goes down and then it goes up. Where's the middle then? The middle is going to be between pi and 2 pi at 3 pi over 2. And it's going to be down, I should have given you guys more room. It's going to be down right here. Where does it cross the x-axis? At pi and 2 pi, right? So it does the little bending shape. It bends back. So we have kind of that little U. Does that make sense? Okay, so let's try to do it without drawing the first one. So if you can draw it without drawing cosine and sine out first, that will save you some time. So we know cosine starts at 0, 1, sine starts at 0, 0. Okay, can you keep those straight? Okay, so this next one. So if I have negative 1/2 sine of x minus 1, tell me what you know about this. How's it different than sine of x? Yeah? Down by, what do you mean by down by? So vertical compression by 2. So I'm going to say by 1/2. I'm going to have those y's, which means that my amplitude, pre-calc word, is equal to 1/2. I'd never say negative 1/2. It's always a positive value. What's the negative do? A reflection, right? So reflection over x-axis. And then the minus 1? Down 1. Oh, jeez. The hardest time drawing like straight lines on here. Okay. So if I was approaching this problem, I always think, okay, what's my period? Has anything affected my period of 2 pi? Do I have a horizontal stretch or compression? No, I don't. Not horizontal, right? I have vertical. So I still go to 2 pi, so I have it and have it again. I then look for what I call my equilibrium line. Have I moved up or down off of the x-axis? I did. How much did I move up or down? I moved down 1. Okay, that's going to be the new, kind of like the new x-axis. So what I do is I draw a dotted line. And after many years of teaching and tutoring this topic, I determined the best way to show people is to actually draw 3 dotted lines. Because students get a little crazy and sometimes they're like, woo! And then it's like not really symmetric. And it's really high and then really low, like really not low. So we want to go up off of this. How much? We want a vertical compression by 1/2. We want an amplitude of 1/2. So what's my highest y value I have, and what's my lowest y value I have? My highest one is not 0.5, negative 0.5, right? It's below the axis still. Does that make sense? And my lowest one is negative 1.5, right? So I'm going to draw something at 0.5, and this is going to contain my curve because it gets a little crazy if we don't draw this in. It's like handwriting class when you were in elementary school. Do you remember handwriting? My son is terrible at handwriting, and they're always writing, keep all your lowercase letters the same size. It's like that. Remember your little handwriting thing? Okay, and this is the sine function, which normally starts at 0. So I'm going to draw this, but don't draw this in. It usually starts at 0, and it goes up, down, down, up. But what's wrong with this one? I can't go up, down, down, up. It has a reflection, right? So how are we going to do this? It's the opposite, yeah. So it's going to go down, up, up, down. And that's your graph. So exciting. And it continues. So if you wanted to continue on the left and the right side, you could. A lot of textbooks will say include 2 full periods. So if you're going to include 2 full periods, then you'd be like, okay, up, down, down, up. That would be 2 full periods. Okay. Next one. So how has this been transformed from y equals sine of x? So we have a vertical compression by 1/4. What about that 3x? What do you think, Hallie? Not a stretch, though. Close. Horizontal compression. Remember, when anything's in with the x, there's kind of an invisible parenthesis here. When anything's in parentheses with the x, it does the opposite of what it says. So if it says -5, you actually go to the right 5. If it says times 3, you actually divide by 3. So it's a horizontal compression by 1/3. Okay. What does this mean when we have a horizontal compression by 1/3? How does it change my graph? Greta, what do you think?
The x values are divided by 3 or multiplied by 1.
The x values are divided by 3. So the new period is what?
2 pi over 3.
Yeah. The new period is 2 pi over 3. Okay. I'm not going to graph both. I'm just going to graph the second one. That's fine. So I told you guys, as you were drawing this, you want to come up with 5 points, okay? That's going to help you draw the up, down, all that, okay? So this is no longer 2 pi. What is it going to be? 2 pi over 3. And then we're going to have half of that. What's half? It'd be 2 pi over 6, which is really pi over 3. And then you have half of that and in the middle of that. These are the ones that I was saying, I don't care a lot. I mean, some teachers will make you like write down every single one. I don't care that much. This one's easy. You guys know what half of pi over 3 is? Pi over 6, right? This one's a little bit harder. Do you guys see why that's harder? It's like, ooh, it's the average of those two things. You can think of this as 2 pi over 6, and you can add another pi over 6 to it. That would be 3 pi over 6, which is pi over 2. Okay, but I'm not going to care too much about those ones. I just want to see the end of the period and the middle of the period. Okay, we have a vertical compression by 1/4, so what's my amplitude? Yeah, 1/4. You can use fractions with your friends. So we're going to go up to 1/4 and down to negative 1/4. But otherwise it looks just like sine. So we're going to start here, we go up, we go down, and then we go up. And that's our period. Okay, so on a scale of 1 to 10, where are we at with this? Are you guys feeling like this is like at least a 7? Are some of you guys at least a 7, like I understand how to do this? Are some of you guys less than 7? Maybe like a 5, okay. Practice does make perfect. The more you practice, you're like, oh, okay, I get this. All right, let's try these last two, and these will be the last ones for today. So find the period and the amplitude, sketch a rough graph. So these are pre-calc words. Period has to do with horizontal stretches and compressions. Amplitude has to do with how high or low it goes, right? So what do you guys think for amplitude? That's usually the easy one. What is it? 4, right? Because we go up by 4 and down by 4, right? Like instead of going up to a height of 1 and down to a height of 1, we now do a vertical stretch by 4. Yeah?
Do we have to take the 2 out?
We do not. So the reason we would take a 2 out is if we had like 4 sine of 2x minus pi, then we would have 2 horizontal transformations and we have to pull it. All right, the period. How is the period affected? We divided by 2. We had a horizontal compression by 1/2. So our period was originally 2 pi, and we divide it by 2. So we get pi. There is a formula for the period. The period is always our original 2 pi divided by whatever our b value is. B is whatever number is in the function here. This 2 times x, that's b. This 2. Does it make sense where that comes from? Yeah, because you're just like, oh, I'm going to do 2 pi over b. So we're not just memorizing things, we're knowing why we have these things. Okay? So if I'm sketching a rough graph, that means I have a total period of pi, then I'm going to have half of it, and then I do half and half. There's no shifting to the right or left. It's the sine function, so I start at 0, 0. And it goes up to a height of 4 and down to a height of negative 4. So we go up, down, down, up. And that's our graph. Okay, you guys try the next one. It's cosine this time, not sine, so be careful. Yeah, these ones are weird ones. We actually didn't put any on your homework like this yet, but we will eventually. We were like, oh, that might be a little hard for them. Okay, so our amplitude is definitely 1/2. And our period was originally 2 pi, but our b value is pi over 3, right? There's a pi in there, which is kind of weird, right? If it had just been 1/3 x, you would just take your 2 pi and you'd multiply by 3, and you'd be like, oh, my period's going to be 6 pi, right? But we have a weird pi there. So we're going to divide out by that pi over 3, which ends up multiplying by 3 over pi. So your period is actually just 6 units long. It does not involve a pi at all. So if we sketch it out, we just go out to 6. And then half of it's 3 and 1.5, 4.5. Do you guys see how I've got that? Because the pi was in there. It's kind of strange. And then we go up to a height of 1/2 and down to a height of -1/2. Okay, but be careful because this is the cosine function, so we don't start on the equilibrium line. We don't start here at 0, 0. We start at what was originally 0, 1. So we're starting at 0, 1/2. And we're going to have to go down and then back up after 1 full period. So in the middle of that is the lowest point. And then the other ones are where we're crossing 0. And so it's always hard for students because they always want to be like, oh, it's an absolute value shape. And I'm like, no, it's a sinusoidal function. It needs to look like a wave, right? So we have to do down and then up like that. Does that make sense? You guys get it? Okay.